Hey guys, welcome to my channel, and in this video I am launching a small course on monotonic stack in Leetcode, right? So basically the way that we are going to do is that there are a total of 61 problems on monotonic stack in Leetcode, and today we are trying to do all of the problems one by one. So in this video I am going to do this problem, which is the remove k digits problem, right? So let's get into it, right? I have already given the solution which I've written, but I'm going to code it again, and while I'm coding it I'm also going to explain in a bit of detail, right, how I came up to this solution, what were the various steps that I followed. Like obviously if you see at the submissions, I've made a lot of mistakes here. I've gone a lot of TLEs here, but ultimately I was able to code it up. So I'm going to walk you through all the steps. It's not an easy problem, but as we do more and more of problems on monotonic stacks, right, these problems will become much more easier for you to understand and grasp. So one of the reasons why I want you to do all problems from one topic like monotonic stack or graph or whatever, that so that these problems you are able to understand the patterns in the problem and you're able to solve those problems easily, right? So let's get started. This is the remove k digits problem. Okay, so I'm going to read it very fast. Given a string num representing a non-negative integer num and an integer k, return the smallest possible integer after removing k digits from k. So I'm gonna minimize this screen here and make it into like a split screen of sorts, right? And then I'll just quickly draw the second part in Canva, right? Let's say given a string num representing a non-negative integer num and an integer k, return the smallest possible integer after removing k digits from num. So if you look at this number, right, 1432219, let me just write this thing down here, right, 1432219. So you have these numbers here, right? So what is saying is that I can remove k digits or 3 digits from this number. So I can either remove 4, I can remove 3. So let's just say I remove 1. It becomes 432219, right? It becomes 432219. If I remove 4, it becomes 132219. So similarly, if I remove two numbers 4 and 3, it becomes 12219, right? So it has said I can remove three numbers. So let's say I remove 432, it becomes 1219. That is the kind of number you are getting if you're removing something, right? So that is my problem statement here. If you see, it's 1219, which is 1219. So what they have removed is they have removed 4 3, right, and they have removed 2, right, 4 3 and 2. So that's how they are getting 1219. Now why they are getting 1219, let's see here, right? Return the smallest possible integer. So if I remove three numbers, let's look at the problem a bit, right? Remove three numbers, some possible combinations I'm going to write down, right, where I'm in each combination I'm going to remove three numbers from here, right? Let's just say I remove 4, I remove 2, I remove one random combination 1329, right? And then I remove 4, I remove 2, I remove 9, 1321, like that, right? I'm just removing three numbers, right? 1, right, 3219. Now which one is the smallest, right? Obviously like if you are to do it like this, like you will realize that the smallest is always going to be 1219, right? So how do you find out that which one is the smallest number, right? You need to start from the smaller set of input 1 0, right? You have this 1 0, and it said 2 is to be removed. So if I remove both of these numbers, I'm going to get 0, right? So the point is, when you are starting off this kind of problem, right, the first thing that you need to know, because you are just starting with this problem, is that we are going to look at the topics and it is going to use monotonic stack, right? If you're doing this pattern more and more, the more and more you do that, you will look at a pattern like this and you will understand that, okay, I have to use monotonic stack here, right? The interviewer does not need to, like, you don't need to look at the hints and know, right? So now let's start, right? Let's start thinking, okay? And the thing is, right? I'm going to explain this to you, but if you do not understand, okay, don't panic if it feels too complicated to you, because I've done this kind of problems before, and when I started doing this kind of problems, the issue that happened was that initially I was not understanding. If you see that, if you see the submissions, I have made a lot of wrong answers, right? And then when I understood the pattern, I came back and I am able to solve it now. Okay, so there is a pattern to be seen in all these kind of problems, right? Let's just say that this is 143219, right? If it's saying that remove three digits from the number, right? So what are the 3 digits you can remove? Just think of it, right? If you see, this is 1, okay, it's increasing, it's becoming 4, then it decreased again, right? Now when you look at this, right, if I have to remove 1 digit from this number, right, just think in the greedy manner. Okay, take some hints right now, take some hints that we have to think in greedy manner. Okay, you need to think in the greedy manner, right? So I'm thinking in the greedy manner. First I'm going to start with k equals to 1. Okay, so I'm going to start like remove 1 digit from this number such that this becomes the smallest. Okay, not thinking of removing 2 digit, 3 digit, just remove 1 digit. So find out all the combinations there are. Okay, and I'm over explaining it a bit, but eventually, you guys should be able to get it on your own. So much of over explaining. So I'm removing 1, right? I get 432219, right? I'm removing 4, I get 132219. I'm removing 3, I get 142219. I'm removing 2, I get 143219, right? Think a bit more. Okay, how far have I gone? 143219, right? So I remove this 2, I get 14319. Sorry, 2219, so 143219, right? And then I remove this 1, then I get 143229, right? 2219 I think it was, and then finally I remove this 9, so I get 143221, right? So out of these numbers, which one is the smallest? If you look at it, you will realize that what happened when I remove this 1, right? So see, the first thing is that there are 1 2 3 4 5 6 7 digits in the number, right? 7 digits. So right, think of your observations that you're gathering from here, right? This is not an easy medium problem. Actually, this is kind of a hard problem only. So you need to just try to think in my direction, the way that I'm nudging you to think, right? So 7 digits in the number, right? What happens if you remove any 1 digit, right? K is 1, so if you remove any 1 digit, it will be 6 digits in the number, right? Like there is nothing that you can do to not make it 6 digits, right? It's going to be 6 digits, right? So our job is to minimize the 6 digits, right? So now think here, if you remove the topmost digit, which is 1, what happens? Now the a bigger digit than it takes its place, right? 4 is now the top digit. If you were to remove 4, 1 would be the top digit, so it becomes smaller, right? Now so if I have to remove one number from this series 1 4 3 2 2 1 9, which number am I removing, right? Which number am I removing? So look at it. 1, then 4, it's increasing, right? And then 3, it's decreasing. So what if I'm removing 4, what happens is this 1 comes in the 4th place, right? So the number is decreasing, right? And the rest of it is basically staying the same, right? So think of the impact that you are having, right? Let's just say if I removed 9 from here, right? These numbers will shift, right? All of these numbers will shift. So 1 comes in that place, 4 comes one place before, right? But think of the impact that you are going to have if you're shifting 9, right? Let me remove all this. Or if you're shifting any other number, our impact, right? When it comes to numbers, your goal is to have an impact on the like when it comes to any numbers, right, whenever you come across this kind of number digit problems, the goal is to have an impact on the rightmost side, right? If you can have an impact here, if you can minimize this digit, then it's worth than minimizing all of these digits, right? So the way, if I look at this algorithm, right, if you see at some of the examples, right, how I'm coming up to it is then 1, then 4, right? And if it's going lower, right, if it's increasing and it's decreasing, then I take that point and I'm going to remove that number that is decreasing after this 4, right? So this is increasing in nature, because if I now two situations, right, two counter situations, right, start from, let me try to write down a very rudimentary algorithm, right? Start from left to right. Okay, now if the number is increasing, right, so there can be two conditions happening: either the number is increasing, either the number is decreasing, right? Now try to think what happens if the number is increasing and you are deleting, right? So I start from 1 and I go to 4, number is increasing, right? The next number is increasing. So what if I delete 1 now? Now the 4 number, which is a bigger number than the 1, is going to take the first place, right? Or it's going to take its place, right? So 1 is going to take 4's place. I don't want that to happen, right? I don't want that to happen, because it, instead of that, if it's decreasing and I have this 4 take this 3's place, right? Let's just consider this scenario, right? 4 and 3, right? So if I remove this 4, right, because 4 is coming before 3 and 3 is decreasing, then 3 is going to take 4's place and 1 is going to take 4's place, right? So it basically gets shifted, because 1 3 2 2 1 9, right? So if you look at this, then this becomes a lower number, right? So if you have a number like this, right, now think of it, 1 2 3 4 and then 0, right? Think of all kinds of examples. And like I said, right, it's more about, the more you practice, the more you understand this kind of problems, right? So 1 and then 2 is increasing, and then 3 is increasing, right? So if I am to eliminate any number in this set when it's increasing, right, if I eliminate 1, then 2 takes the first place. If I eliminate 2, then 3 takes the first place, then it becomes 1 3, right? So the number is increasing, but why am I doing this? But if I eliminate 4, then 0 takes its place, right? And these numbers get shifted, right, which is kind of what I want, right? It's not something that I can explain that easily to you, but if you play with these numbers, you will understand slowly, right? And now I'm slowly trying to build this algorithm. If you're not able to understand, just tell me that, right? And again, this is something that you come with a lot of practice, right? If the number is increasing, keep iterating. Okay, iterating. Now I am at index I, right? I'm at index I. Now if num I is greater than num I plus 1, just try to look at this, right? If num I is greater than num I plus 1, right? I already explained this, 1 4 3 2 2. So if 4 is greater than 3, what happens if I remove 4, right? Then 1 takes the first place, right? 3 takes the second place. Think of it, everyone's at a win-win, right? And the rest of the digits kind of stay the same, right? And I have created an impact at the top right? So num I is greater than num I plus 1, remove num I. Okay, remove num I, and basically if k is 1, this is how this works, right? I'm going to remove that number. Now what if it's just increasing in nature, right? What if it's just increasing 1 2 3 4 5, right? 1 2 3 4 5. Which one do you think, again, this is math, right? Which one do you think should I remove if it's just increasing in nature and I have to remove one? I'm obviously going to remove the last one, right? because each of these digits is going to shift. One is going to take 0th place, 1 2 3 4 it becomes, right? If I remove any other digit, then it's going to be larger. The larger number takes the first place or something like that, right? If I remove 5, it becomes 1 2 3 4, right? If I remove 4, it becomes 1 2 3 5, which is obviously greater, right? Again, this becomes your muscle memory, right? Just stop and think a bit, right? If you're not understanding, right? So if num I greater than num I plus 1, remove num I, right? And then you do a k minus minus, right? You're doing this, and then now once you're doing this, removing num I, and you're doing a k minus minus, right? And now once you're at the end, right, check k. If k is greater than 0, which means I have not covered on, remove last k elements and print, right? Print, very simple. I'm just going to so I'm done with this, right? If I need to also there are some edge cases. Obviously, if k is greater than, if k is greater than the length, then that means I can just remove all the elements, right? If k is greater than equal to this, then I can just remove all elements, and then I'm going to just print it out, right? So this is basically the algorithm. If you look at it, right, I'm going to start from left to right. If the number is increasing, then I'm going to keep iterating. Whenever I encounter a number like this 4 0, right, decreasing, right, then I'm going to remove this 4 and keep iterating, right? And then I'm going to remove num I, and then once I'm at the end, right, whenever I'm removing something, I'm going to do a k minus minus, right? When I'm removing something, right, then 3 becomes the next number, right? Then I'm checking 3 with 0. Okay, 3 is again bigger, then I'm going to remove 3. Then 2 is again bigger. If k is 3, right, then it becomes 1 0. And then if I have to remove 4, then I'm slowly going to remove all this 4, right? So the way, now how do you solve this, right? Now how do you solve this? Think of it. What's the best approach to solve this kind of problem? I've already established the algorithm, right? The easiest way to solve this problem is you initialize a stack, right? You initialize a stack. Let me see if I can get a stack here. Okay, but okay, I don't have a stack, but I'd want you to think of a stack, right? Let's just say, so I initialize a stack, right? I'm just going to make it like this, right? So that you guys can, okay, I have this beautiful thing here that can help me draw, right? So this is a stack that I'm initializing, right? Sorry about this. Yeah, so this is a stack that I have, right? And within this stack, I'm first going to put 1. Okay, so 1 is, I'm going to put 1, and then within this stack I'm going to put 2, because 2 is increasing in nature, right? So I'm going to put 2, and then I'm going to put 3, right? Let's take this example, right? 1 2 3 4 0, right? Then I'm going to put 4, because 4 is greater. And now when I'm going to go 0, right, now I'm going to go 0. Now I'm going to compare the top element of the stack with this 0, right? And I'm going to see that the top element is greater than 0, right? So what I'm going to do, I'm going to pop this top element, right? I'm going to pop this top element. So I'm going to pop this top element. Now what happens is, where is my eraser? Yeah. So once I pop this top element, now I have 3 2 1, right? Now same thing, I'm going to compare 0 with 3, right? 3 is bigger than 0, then I'm going to pop this. Like k is 2, right? K is 2 here, right? Sorry, I forgot to mention this, but k is, let's say k is 3 here, right? K is a number, right? So I can pop it like this, right? If k is 3 here, I'm popping this, right? If k is where is my drawing pencil? Yeah. So if k is 2, again I'm popping this also, right? Because k is 2 is greater than that, and k is 1, then I'm popping this also, right? So the entire thing becomes empty, and now I have an empty stack, and then I can again push 0 into the stack, right? So the stack just has 0 in it if k is 3, right? If k is less than 3, then obviously there's going to be more elements. So there are all lot of edge cases if you can think of, so that's why it failed so many times. But now I'm going to go to the coding part, right? As I go to the coding part, I think you guys will understand a little bit better these things, right? let's understand the code a little bit, right? Let's understand. I'm going to redo this code, right? String num integer key, right? So what I'm first going to do is stack. Okay, let me write this code here because I write better code here, right? So stack integer st equals to new, and I'm thinking this on the fly actually. So I created a stack, right? Now what does my algorithm state, right? I'm just gonna take it here, right? Where is it? Yep, right. So I'm just going to take it here, start from left to right, right? So I'll create a for loop, I equals to 0, I less than num length I plus plus, right? So I'm starting from left to right, right? I'm starting from left to right. If the number is increasing, then you keep iterating, right? So firstly I'm going to check if the stack is empty or not. If stack dot size equals to 0, right? If the stack size is empty, then I'm simply going to add the so number is a string, right? It's a very big number, so I'm just going to get the number that is there. So n dot caret I minus 0, right? Because it's 0 1 2 3 to 9, so I'm subtracting it from 0. So I'm converting from the character num to the integer num, right? So n1 is the integer num right now, right? So if st dot size 0, then what did I say we'll do? We are just going to push, right? St dot push n1, right? So I pushed n1 in there. Now let me think, if the starting from left to right st dot size is 0, then I'm pushing n1, and then if the number is increasing, then we keep. If it's not 0, then what does the algorithm? I'm basically writing a rudimentary algorithm, not going to look into the edge cases and stuff like that, right? But we'll together look into the edge cases, right? So if st so the topmost element of the stack I'm going to compare with the current number, right? So st is not null. So if n1 is greater than st dot peak, okay, so I'm just going to peek into the topmost element of the stack, and I'm going to see that if n1 is greater than, right? So what do I do, right? It's greater, right? My k is non-zero, right? Additional condition, if k is 0, nothing, we just break, right? And k is greater than 0. What do I do? If again, this can be optimized further, but just bear with me for a while, we'll optimize it, right? If n1 is greater than st dot peak and k is greater than 0, what should I do right now? I should remove that num I, right? So st dot pop, just think of it, we already discussed this algorithm. St dot pop is going to remove the topmost element of the stack, right? And when do I push n1, right? So when do I push n1? Actually this will not be an if, this should be a while, because until that is greater than 0, right? One more edge case. If I am doing this, right, it's very much possible we will come across cases like that, when the entire stack goes empty, right? xt dot size greater than 0 and n1 st dot peak and then k greater than 0, right? St dot pop, whenever I'm doing an st dot pop, I need to do a k minus minus, right? And whenever so one element is going down from k, right? So once you are at the end, check k if k is greater than 0, right? So this keeps going on, right? And I'm going to do an st pop, and then finally let me look into it. So what have I done? St dot push n1, otherwise st dot pop, and then k plus I is self incrementing, right? So whenever what happens whenever I'm doing an st dot pop, right? N1 greater than, should I decrement I also? Let me look into it. N1 greater than st dot peak and k greater than 0. Okay, this is okay. Now what I'm going to do, if k is greater than 0, right? So while k greater than 0, if k is still greater than 0, then I'm going to just keep doing an st.pop and k minus minus, right? So until k is greater than 0. Now string res equals to, there's a good probability there will be errors, right? So we'll solve it together. Again, like I said, I'm making it a very unedited video because I want you guys to get the intuition behind how I'm doing this problem, right? But you can understand how much time it took me, right? But anyways, okay, this is not a for loop. So while st.size is greater than 0, right? While st.size is greater than 0, then st.pop, right? Res equals to st.pop plus res. So the reverse order in the stack, right? But return res, right? Now this should work. Okay, we will encounter edge cases right now, and we are going to handle those edge cases, right? So I'm going to run this code, right? I hope you guys understood certain things, right? Test case first, I'm going to reset all the test cases, right? And then I'm going to run this code. Let's see. Runtime error. Okay, while k greater than 0. Okay, st.size is greater than 0, right? Because if k is still greater than st.size, what happens is edge case. See, we will run into edge cases with this problem. First one is wrong, right? Why is it wrong? My output is getting empty and it requires me 1219. So how do I debug this? Okay, let's think of how am I going to debug this. I've come across an error, right? I'm going to look at the problem from the first to the end, try to understand stack integer st. So for this input, right, how is it going, right? Stack integer st, integer n1 num. I'm going to do a dry run. Okay, n1 is num dot caret I minus 0, right? I start from 0, num dot length minus 1. If st dot size is 0, initially st dot size is 0, so I'm going to push n1. So it pushes 1 into the queue, right? While st dot size is greater than 0. Now from the next iteration, it's greater than 0 and n1 is greater than st dot peak. But I made a mistake here. I did not consider the condition that what if n1 is less than st dot peak, right? So condition I did not consider. Now I'm going to have to break this down, right? So let's see, n1 greater than and k greater than 0, right? But in general, k minus minus, right? But so what is the other thing I can do? If n1 is less than st dot peak, I should still st dot push, right? So if st dot size equals to 0, then continue. Okay, and this keeps going on, right? And once this is done, what is it going to go? St dot to push n1. See, I forgot this part, right? n1 greater than st dot peak. Once it's done, it should, now I'm pushing n1 and I'm going to do a k minus minus. Let's say if this solves my problem, or if there's still more problem. Say 4 through 2 9. Okay, I made another mistake. Okay, let's see now what is the second mistake that I've done. Okay, n1 is 0, st dot size is 0, then st dot push n1, continue, and then while st dot size is greater than 0, n1 is greater than st dot peak and k is greater than 0. So until k becomes 0 or this happens, right? Okay, and I'm going to keep st dot popping, and then once I'm done with it, I'm going to just push n1 into the queue, right? So if stack size is 0, this happens, and I'm continuing the loop from the next element, right? I can't just, okay, this is cool, but let's understand why did it so 4 is less than 3, right? So I took 4 in and then I took 3 in. So whenever I'm taking 3 in, 4 4 is greater than 3, right? So it should be giving me, and it should take off the 4. Instead it's taking off the 1, which is weird. So I'm thinking n1 should be less than st.peak, which is another mistake that I've made. Can you understand why this is a mistake? I'm doing it in the reverse order. See, this one work now. 1 to 19, 1 to 19. Why is second not working? It's 0 to 0 0, but I'm expecting 2 0 0. See how I solved that silly mistake, right? I looked at it and I did a dry run in my mind, and I saw what was happening here, right? But this is a more easier silly mistake. This is not even a silly mistake. This is just I'm going to remove trailing 0 here also. If it's 0 then 0, then these are more common things. So return res is just at 1 point. So there is this I saw that your string dot trim start 0, right? So I'm just going to add this, not this, let me add this, replace first. So any trailing leading zeros, I'm just going to remove it, right? So return areas dot replace for 0 0, right? Let me do this. String r1 r2, right, equals to this, right? This is my result. Now if r2 equals to if it's empty, right, if r2 dot length equals to 0, return at minimum I should return a 0, right? Else return r2, which is cool, right? So if I done this, let's see what is going on. Sorry, one more error. R2 dot length equals to, okay, length, it's going to be like this, right? It's okay to totally make mistakes, but eventually you're supposed to get better. My test cases are working. Let me see if I can get the, please work. Yeah, it worked. Okay, so one more walkthrough of the code, just for guys, if you don't understand it or something like that. Take a stack, right? Let me move this code to Canva or something, maybe, or I'll just do it like this, right? I'll just put it here, right? And on the left side I'm gonna open up Canva or something like that. Where is it? Yeah, this is my Canva, right? So what I'm going to do, simple thing, right? Take an empty stack, right? Take an empty stack, and then for push elements into the stack, right? I'm simply pushing out all kinds of elements into the stack, right? Whenever before pushing, see if there are any elements in the stack which are bigger than the current element, right? If bigger element is there, remove those elements as long as k is greater than 0, right? Now once this is done, push that element in to stack, right? Now once you have pushed that element into stack, now once the whole thing is done, once entire string is looped through, return it from pop convert the stack to a string and return it, right? So this is basically the algorithm. As you can understand, it's a little bit more complex than like something that could be explained very easily. You need to do a lot of problems on monotonic stack in order to understand this algorithm. I hope you guys liked it, and I hope you guys were able to understand what I was trying to convey through this algorithm. I really hope you guys watch the whole video, right? And I'm going to drop this solution in the comments. Just tell me how I can make it better if you guys watch the whole video and still don't get it, but I'll definitely try to help. And yeah, that's it for this video. Okay, I'll see you for the next one.